All right, this was you last time, right? We did this together last time?
Yeah,
Okay.
yeah, it was, you said, very obvious, but require.
Okay. All right, we're going to continue where we last left off. So this is the design recipe for data definitions. So what is the data definition?
Uh, I can read the definition of relationship between data and information. Yeah.
Okay. Yeah. And we saw that there are many ways to represent information. We see one
Hmm.
example in which we just straight up use a data type. We have learned about data types last time. We can straight up use it to represent information.
Hmm.
So in our case, let's say temperature, right? We represent temperature with a number.
An int, yeah.
Yeah. Oh, not just an integer, right? It could be decimals as well.
A float, a big int. Yes, yes.
Okay. Now, well, I'm gonna move on to a different concept. I'm gonna talk about writing functions or designing functions.
Hmm.
So the same way that we have a design recipe for data definitions, we have a design recipe for functions. So there are a series of steps. So
Hmm.
let's say here's the situation. Uh, let's say we are designing a function that converts the given temperature in Celsius to Fahrenheit. Okay?
Yeah.
So let's say that's our situation. The first two steps of the design recipe, first write the signature of the function. Remember, what is a function?
Uh, I give you a definition.
Yeah, what's a
It's
function?
some a function can be a set of instructions that receive something and give you something, input
Okay.
output.
So input output is what I'm looking for. Yeah. So input to output, right?
Hmm.
Here refer to the types and data definitions. Okay.
Hmm.
So so for our function here, the I'm just gonna write this function Celsius to Fahrenheit. Uh, so that's just a stub. I just write the function, but I don't implement the body yet. So for the signature, first it takes in the temperature and it produces a number. Okay, so let
Hmm.
me explain. Why does it take in a temperature? Well, they're asking me to design a function that converts the given temperature from Fahrenheit to Celsius.
Yeah.
Is there a data definition that represents temperature in Celsius?
I think T0C, T1C are temperatures, no?
Yeah. These are examples of temperature, but
Yeah,
our
yeah.
data definition is line 27. A temperature is a number,
Ah, yeah, yeah,
right?
yeah.
The temperature in degrees Celsius. So on line 44, when I say temperature, I'm referring to the temperature in line 27, right?
Uh-huh.
So what does it produce? I can't say it produces another temperature. So for example, if I write this, it's not exactly correct. Why is this not exactly correct? Line 44.
Because I don't know, a temperature is a number, and you want a number to represent temperature, so I don't know why this is incorrect.
So what is the interpretation of temperature? Our temperature, the one we defined.
A scale, a unit,
Well, let's look at line 28.
only not like 98. Temperature in degrees Celsius. So since it's Fahrenheit, now it's not temperature, it's something new.
Exactly. Our previous data definition no longer applies, so we have to do something different. For now, keep it simple. Just say number. Okay?
Mhm.
But how about this? Can we do this?
Yeah.
So we can, but it's not as good, right? It's not as specific.
Alright.
But do you agree with me? It's not as specific?
Because you don't know the type of data.
Well, like compared, like, so we have So we have two options, right? We do this or we do this.
Mm-hmm.
I claim that the first one's more specific than the second one and it's better. Do you agree?
Given our definition in this, yes,
Yeah,
because we haven't defined we know it gets the temperature, but we haven't defined temperature as having Fahrenheit. It's only Celsius. So
exactly.
yeah, it will be better, but I still don't get it. It's only based on our definition at the moment.
Yes, and our definition is everything. This definition is going to build the foundations of our program. Okay, so for
Hmm.
now, trust me, for now, we'll move on to a different example that will make it more clear. But I'm trying to introduce this idea that we can refer to our existing data definitions in our program. So in our case, line 44, temperature, we can refer to the temperature in line 27, right?
Hmm.
Okay,
Yeah.
so that's the first step. We write the input output. Next, write the purpose statement. So
Like the a small like comment explaining the function.
exactly, yeah. What does the function compute? What does it do? So you can say produces the Fahrenheit temperature in Fahrenheit from the given
Equivalent.
temperature in
Hmm.
Celsius.
Yeah,
Okay,
sure.
so that's the second step. Third step,
Oh,
example slash test. So for example, where Celsius to Fahrenheit. So a classic example is this 20 degrees Celsius. Sorry, 0 degrees Celsius. What is 0 degrees Celsius in Fahrenheit? Do you know?
32.
Yes, 32.
I'm
Um,
from a Celsius place, so I don't know a lot about Fahrenheit.
I see. So this one, so just mix and match some good examples. There's,
The
let's
boiling water,
say, sorry, what?
the 100 or what, which one? And 7.
Oh,
Okay,
so
okay,
I
yeah,
decided to
yeah.
use negative seven. So I like to use a mix. Have a negative, have a positive, have decimal, have a good mix.
Okay, okay. Yeah, yeah, yeah.
Um, I can Google this, but I believe, oh, it's been a while.
I can Google it.
I no, I think I remember. I remember. I did this just now for another student. That's why I remember.
Okay, I have
I
the
think
answer
it.
if you
I
want
think
it.
it's this times 9/5 and then everything plus 32. So when we're testing, right, we're allowed to do this, where we just straight up write the computation. That's okay.
All right.
So I'm going to pick a positive example now, which is 6.8. I want to do a positive decimal, mix it up, right?
Mm-hmm.
Oh, you ran the math.
Well, just just to have it here.
Okay. Okay. I want to show one more. So usually I'm satisfied, but there's an interesting property about this particular function. For
Mm-hmm.
-40, it produces -40.
Mm.
So it
Negative
has
4.
at -40, it has the interesting property that it's gives the same thing. So
Oh, nice.
it's nice whenever you're dealing with a function that deals with like numbers, it's good to capture properties like this.
Mm-hmm.
Okay, for now we'll leave it at that. So third step is done. We have some examples and tests. Fourth step, you guess it, we write the body of the function.
Okay. It's just the formula, no?
Yeah.
Yeah, well, you already have the.
So as you can tell, I'm just gonna see, oh, we have the formula. I copy it, I paste
Mm-hmm.
it, but we have to
Mm-hmm.
generalize from the specific values. So I put in C.
Yeah, let's see. Yeah.
Now let's run it. All passed. Okay.
Okay. I
Make
run
sense so
it.
far? Yeah, yeah,
Yeah,
run
yeah,
it.
yeah. Run.
Any questions so far?
No.
Okay. So I've done a lot of explaining. Now I'm gonna explain a little bit more, but then I want you to write the rest of the code. So I'm gonna give a new situation. Okay. Okay, you work with microcontrollers, so I guess this is not new. Maybe this is a very familiar situation. Let's say we are writing code for traffic lights. Okay.
Hmm.
So the first thing we need, so the first thing we need to do is we need to think about what information we are representing. So in a traffic light, what information is there?
The yellow, green, red,
Okay,
the
yellow,
color.
green, red. So, but can it be all of them simultaneously?
It could be a list.
It could be, sorry, what?
A list.
A list? What do you mean by
Like
that?
um, um,
Okay, I'm
like
not
the
worried about
same
representation yet. I'm worried about information still. So let's not think about how to represent this. I just want to capture what information we care about. So what's the information?
colors.
Okay, but three specific colors, right? Red, yellow, and green.
Hmm.
But can a
Yeah.
traffic light be, can all three lights be turned on at the same time?
No,
Okay.
I don't think so.
So what more information is there about traffic light that we're missing?
Well, time. If you want it to be advanced, you need traffic. Um,
No, I'm focusing more on the nature of the lights. So we know that they can't all be turned on at the same time.
the nature of the lights, like the
Yeah.
voltage for each light. I don't.
So okay. So here, so traffic light, we know that there are red, yellow, and green lights.
Yeah, yeah, yeah.
They cannot all be turned on at the same time.
Ah, like the
What?
rules.
Yes, yes. But
Only one at a time,
so one at a time. That's the important idea. Only one of red, yellow, and green can be on at a time. Okay?
and each one may have its own time.
Okay, I'm not
Like,
gonna worry about time for now, just to
uh,
simplify the situation. But
uh,
this line 65, only one of red, yellow, and green can be on at a time. This is what I want to capture. So this is our information. Okay?
mhm.
So this is what I want
Yeah,
to capture.
yeah, that's what I was thinking. A list because it can only be one at a time.
But a list is has all of them simultaneously, right?
No, but if you only choose one, but yeah, 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 you have all.
Okay. So what I want to talk about is so typically what we first start with is we say name of data definition is representation. All right, this looks familiar.
Yeah, it's what we have before.
Yeah. So
Mm,
last time for name of data definition, we had temperature. For representation, we have number. So at
mm.
first, I'm going to give this a name. I'm going to call it traffic light. All right. But how do we represent this?
Boolean on or off.
Boolean. Okay. How does the Boolean represent red, yellow, or green?
Well, you are representing when they are on or off.
So can you
No,
be specific? How do we use the Booleans?
like make them all false when they are all off.
All false. What do you mean by all false? What are we making false?
If the light, like a variable, is the green light on, equal
Okay.
false.
Let's say we can't use variables. Like for example, the temperature, I say it's a number, right? I'm not saying it's referring to a variable outside. It needs to be self-contained, if that makes sense.
Okay, it can it cannot be a number.
Can be a
It
number.
can no, not a number. Maybe binary,
What do
something
you
like
mean by
that.
binary?
Like 4 bytes, or zeros or off. One 0001 is the green.
Ah,
Zero
okay.
one zero is the red, or what?
So, okay, now I know what you're saying. So what you're saying is,
Binary representation? I don't know. Yeah, yeah, yeah,
No,
yeah,
no, no.
yeah.
You
Something.
you're not far off. In fact, this is actually a valid solution. This is valid. You're saying it's this, right?
Yeah, 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 yeah.
So you're saying a traffic light is one of these numbers,
Mm-hmm.
or I'm gonna write out the oh it's four. This one's four. Yeah. Okay. This is a valid solution, but
Hmm.
so I want to first point out one thing. First, this idea of one off. We have three values, and a traffic light is one of them, right?
Mm-hmm.
We call this enumeration,
Okay.
where
Mm,
we can enumerate or just list a finite set of values and the date and the value of our data definition can only be one of them. Okay?
okay.
So I want to change one thing. I don't want to use one, two, or four. I I'm going to
Mm-hmm.
use strings. Right.
Okay.
There,
And
there are some
because
benefits to using numbers, but I want to keep it simple. I just want to use strings. So far, so good.
yeah, yeah, yeah.
So using numbers and strings, there are pros and cons. The reason why I'm opting for strings is because we don't have to deal with mathematics.
We don't have memory issues.
That also, um, and it's also more readable, right? It's like, oh, is
Yeah,
two green or yellow? It's hard to remember, but I say, oh,
yeah, yeah, yeah.
yellow, it's yellow. All right,
Mm-hmm,
agree?
mm-hmm. Yeah, yeah, yeah.
Okay. All right. I want to take a side tangent. I'm going to share my screen for a moment on a whiteboard.
Okay.
Give me 1 second.
No
Okay.
problem. I'm watching the
So let me
Zoom.
know once you see my screen,
I'm seeing the
the
yes,
whiteboard.
now it's white. Yeah, yeah, yeah.
Okay.
Just now.
Are you familiar with set theory in mathematics?
Yes. I
Okay.
don't I see it. I studied. I don't remember at the moment. So can you remind me? But
Okay.
I did see it.
No, it's okay. You don't need to really know it, but I might reference some terms in set theory. But imagine we have the universe of data. This box here contains all possible data that could exist in a programming language. Okay? For example, numbers like one, uh, oh my God. Sorry, I fat fingered. Okay. Two, three, right? We have our numbers. We
Mm-hmm,
also have like decimals, 3.33. And then over on one side we have booleans, true, false, right?
mm-hmm.
We also
Negatives.
have we have strings, we can say hello. We have
Yep.
um empty string, there's so many strings.
Mm-hmm,
So whenever are referring to a data definition, right, what we're doing is we're drawing a circle around some values. So for example, what I drew over here is the Boolean set, right?
mm.
B for Boolean. This is referring
Okay.
to all the Booleans in the universe of data, which in the special property of Booleans is that there are only two values, true and false, right? So
Sure.
Boolean is a data type, right?
All
We
right.
can also circle the numbers. So I can't list all of them because there's an infinite number of them, but I can say like, oh, these are the set of real numbers, right?
Yeah, yeah, yeah.
So whenever we draw a boundary, not only are we mentioning the set of like what's considered to be the part of the data definition, we're also saying what isn't part of the data definition. So in set theory, we call this the complement. So anything outside the circle around the R is not a real number, right?
Mm-hmm. Yeah,
Like
you told
hello,
me the
yeah. So
the
string hello is
fractions.
not a number.
Ah, yeah, yeah. Hello.
Yeah.
Right.
And then we also have a lot of strings, right? Oh, that's a bad circle. Oh, sorry, I'm using a mouse right now. It's difficult.
But then are in strings represented in bytes. So each character is a byte, and then if you have each letter is a byte, then you have a very big number that can be represented. in integers.
Uh, that's if you go lower level. But for, let's say, like this is universe of data in Pirate. So let me be more specific. Universe of data in Pirate.
Okay,
So if you look underneath Pirate, yes, the string is a number, but if we just look at Pirate, we don't know that. We just see a string, right?
okay, okay.
Yeah. Okay, anyway, so part of the strings is also the strings red, green, and yellow, right? So the circles that are currently on here, these are part of the programming language. These are the data types that comes with the programming language. But what we
Hmm.
effectively did just now is we drew our own boundary. We drew our own circle.
Subset.
Yes.
Mm.
So we drew our own circle and we called it a traffic light, right?
Yeah, yeah, yeah.
And when we were dealing with temperature, we said, oh, a temperature is a real number. So those two sets are equivalent. That's what we were doing just now. Okay?
Alright.
Anyway, what I'm trying to show here is whenever we make a data definition, we are drawing circles around values in the programming language. In the case of traffic light, we draw around red, yellow, green. In the
Mm-hmm.
case of temperature, we are drawing a circle around real numbers. Okay?
Mm-hmm. Yeah, yeah, yeah.
Okay. Technically, you don't need to know this, but I think it's good to know. All right. Let's go back to. Actually, you know what? I'm gonna close this session and open a new one because I think this one will expire soon.
I think we have 7 minutes more, no?
Yeah, but I don't want to cut this in the middle, like while we're doing
Okay,
things.
okay.
So I think it's a good natural break.
Okay,
So
we'll re-enter.
see, yeah, I'll send you a new link in Gmail and I'll see you there.
Okay, okay. See you in two.
Oh, welcome back. Okay, so let's continue where we last left off. Uh, what's
Mm-hmm.
what's after what's the second step of the design recipe for data definitions?
Let me see. It's up here. Um, no, this is for function. Relationship. What is the information? What is the interpretation of the data?
Interpretation, yes. I would like you to write an interpretation for a traffic light.
Like green go, red stop, yellow
Yep, for example,
don't
that's
break.
valid. Yeah, so an interpretation is basically an explanation for the human being for what this means. So if you were to explain this to a 5-year-old, what would you say?
Yeah, green means don't stop. Red means stop. Yellow means break.
Okay, can you write that down on the new line?
Sure. Like this.
Yeah, but could you write that in a sentence?
Mm.
Uh, okay, yeah, sure. No, no, okay, I'll accept this, but I'll modify it for you. This one I was more referring to. Red means, I mean, it doesn't really matter, but trying to get you into the habit.
Okay, okay.
Okay, there we go. So step two done. What's the third step?
Uh, what?
What's the third step of the design recipe for data definitions?
It's examples test.
Okay. So in our case, it's examples. For data definitions, we write examples.
Yeah, isn't it the same as the interpretation? And also, just a quick note. In your screen, I see it. Well, you change it, and I see what you are seeing. But in my VS Code, it I see you modified, but for example, it says Griminso. It has it instead of green it says green. So it doesn't matter, but just for you to know.
Okay,
I don't
sure.
know why it isn't updating,
Okay, yeah,
but
this is a bit buggy. Okay,
yeah,
that's
but
fine.
yeah, no, just for you to know, I don't see that. And
Okay.
yes, we examples. Pues, yeah, if, I don't see how, in this case, how to differentiate it from the interpretations. If the example means, if red means stop the car, the test is when red, car stop,
Don't
something
worry
like
about the
that.
tests yet. Just focus on the examples.
Yes, when the you have just it's the same, just reformulated when the light red is on and the others are off, it means to have the car in yes, no
Okay. So
pronunciation.
By by examples, I mean like values of our data definition. So like for example, like temperature, we had -5, we had 0. These are all values of temperature. What are values of traffic light?
Okay, like and I don't know that.
Yeah,
Yeah,
you're almost
I
there,
mean,
yeah.
I don't know.
So no, you're on the right track. So we need to use variables here. Like when we did temperature, we had variables. We need to do the
Mm-hmm.
same thing here.
Mm, the same thing.
Yes, like if we look at
Uh,
lines 30 to 36, we have variables defined for values of temperature.
like this. Traffic light stop equal red.
Yes, perfect, but not in the comment.
Okay,
Perfect, perfect. Yeah. And what other values of traffic light are there?
and the other two, no?
Yes.
Yellow.
Okay. As a convention, we typically capitalize every word, every letter when it's a constant. So can we capitalize stop, break, and go?
I, I didn't hear that. Can you repeat?
Oh, can you capitalize stop, break,
Right.
and go? Like
Like
all
this.
capital, all capital.
That's
STOP, all capital.
why you
Yeah.
that's convention for what?
Constant. It's something that doesn't change.
Yeah, yeah, no, I
Uh,
didn't hear the word.
Constant.
Hmm. Yeah,
Um,
yeah,
so this applies to traffic light as well, but traffic light is a bit of a mouthful, right? It's a bit long. Can we just write TL?
yeah, yeah, yeah,
All capital. So the L should be a capital as well. Nice. Very nice. Okay. So this is the examples. So something to note here, and I'm going to write this down. Let me know if it's showing up wrong. Uh, since there are a finite set of elements for enumeration data representations, we can actually list all of them, and we should, right? Like for temperature, if I try to list all the numbers, we will never leave
hmm
this call, right?
it's impossible.
Yeah, I'll die trying to do that. But here it is possible. There are only three.
Hmm.
Okay. Is the text showing up okay?
Yeah, yeah, yeah. Right now, yes. I think the
Sh-
other one was
Hmm.
well, it's still messy because uh, you modified one of my comments, so I don't know
Ah.
why it lagged or something,
Hmm.
but it's okay. I can see right now everything as you write it.
Very good. Okay, so I have a task for you. Design the function rotate traffic light that changes the given traffic light using the following rules. I would like you to use the design recipe for this.
Mm, okay, so I like a function. Uh,
Yes,
mm, what's the name? Or take traffic light. Uh, hmm, I don't receive anything here. So, design the function traffic light changes the traffic lights in the following words. That was like similar what I was telling you at the beginning.
yep.
Uh, just like create a list, and when it's over, go back to the start.
I know what you're referring to. I didn't want to do
Yeah.
that because I haven't introduced lists yet.
Ah, okay, okay. But yeah, I was thinking like if the stop, break, go, and restart. Okay, so how to do this in Pirate, because I was thinking how to do it in Python. In
Okay,
Pirate, you
so take
have
it one
this
step at a
thing.
time. Let's focus on line 87, rotate traffic light. Should it take in any parameters?
Maybe initial state,
Sure, yeah.
and then ini is one of these three. Uh,
Okay. Follow the design
che-
recipe. What's the next step in the design recipe?
the test
Not there's two before the tests.
before the test.
Yeah,
I have it written here. Write the signature, write the function, but not the body. Signature, input, output, purpose statement, test.
so yeah,
Uh,
what's step one?
so the function, but not the body, just the
Oh, we,
header.
we
We
already did
already
that.
have that. Yeah,
So what's the one after that?
yeah, the output, but you don't have outputs here. It's like only uh, the final.
Yeah, the final state is the output, right?
Yeah,
So there is an output. Okay, what's the input and what's the output?
initial state and final state.
Okay, and what types are they? Because we describe the signature in terms of types, right?
In terms of types and data, they are all strings.
Any
Traffic.
string? Any
No,
string?
these ones.
Okay, well, and what's the name of this data definition that refers to these three strings?
Uh, I don't know. Did we define it? Traffic? A traffic light?
Traffic light, yes, we did define it. Line 69.
Yeah, yeah, yeah.
Okay, can we write down the signature?
Signature is the comment explaining, right?
Signature is the inputs and outputs in terms of type. So line 49 is the signature, for example.
49.
Yeah.
Okay, okay. So traffic light. Ooh, traffic light.
Sure, but let's capitalize the T and the L, right? Oh, no, no, no. I mean like traffic light full word, but the T and L are capitalized.
Ah, like this.
And T as well, yes. Yeah, can we do that for the output as well? And let's move line 88 to before line 87. And the reason why is because we don't want to hide the signature. We want to make sure everyone knows the signature.
Sure.
Okay. And the reason for capitalizing the T and L is because on line 69, when we say a traffic light, the T and L are also capitalized.
Okay.
the traffic light in line 88 is referring to the traffic light in line 69. Okay?
Yeah,
All
the
right.
same.
Yeah. Okay, so now what's the next step in design recipe?
The purpose statement,
Purpose statement. Very good. So what's the purpose statement of this?
the it gives the nets uh, state given the rules described.
Sure. Perfect. And can we move line 90 to before line 89? Because the idea here is that people can read the purpose statement without having to read the body of the function.
I have been taught that you write what a function does just in the beginning.
Yeah. Except
Uh,
Python. Except Python. Uh,
okay.
okay. What's the next step in design recipe?
Test,
Okay.
right?
Yep. Do you write some tests for this?
So yeah, but I don't know how to like final state is read when ini is. I don't know. Can you do this? Like if ini
Well, we don't have to do any logic here, right? We just need to call the function. Like if we look at the test for Celsius to Fahrenheit, we didn't.
yeah, no,
We,
I know you don't, but I don't know how to define it because
no, no,
you
don't.
only have the final state is a traffic light data, but how do you know which one? How do you specify the state what it should be if you don't know what it was before?
Yeah, so don't worry about the if. We just have to call the function, right? That's what we're testing. We're testing the function.
Okay, I have
So
to
that's
call this
call.
one.
Let's rotate traffic light.
Okay, yeah. Yes. You have the ini there.
Okay, great. Let's pause here. So I would like you to, instead of using the raw strings in line 95, I would like you to use the examples you defined from line 76 to line 78.
Okay,
So TL stops, TL break, and TL go. I'd like you to use those instead. I'll explain why in a moment.
yeah. And just copy paste. Yeah.
Great. So I want to note a few things. The same way that we can enumerate every example for the enumeration, uh, we can also uh, enumerate, how do I say this? We can also test all the possible cases of the enumeration data representation. Okay.
I'm
Um, yeah, and next thing to note is that why did I ask you? Actually, let me ask you, why did I ask you to use the examples rather than the raw strings?
because we have already defined it. And these are traffic lights, not the strings.
Well, underneath there's strings, but what happens if we decide to change it? For example, like, okay, so let me write why use the constants.
I
What if we
like change
decide
the
to
colors,
change?
change because it's a variable. We see it's easier to modify.
So like, for example, let's say we're currently using strings. Let's say we decide to change the number 1, 2, and 4.
Mm.
If we have like
Yeah,
red, 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 like all over our code base, we have to find each and every rate and replace it with 0 or 1, right?
Yeah.
But if we use the examples, we only have to change it in one place, right? We
Hmm.
have this, we just change it to this, right?
Yeah. Yeah. Yeah.
Change it
Yeah.
in one place. So constants allow us to do that by changing one or two places rather than everywhere. Another reason, what if we typo? For example, rate, what happens if here I write RDE,
Hmm.
right?
Yeah.
The code will still
Yeah.
run.
Error.
But what if I do stpaw? What if I typo TL stpaw?
It wouldn't.
No, TL stpaw will be a
It-
syntax error, right?
yeah. It's
If
undefined.
yeah, if we run now, we'll say, oh, it's undefined, then we know, oh, we made a typo. But if we write RDE in string, we are not going to get a syntax error. The code will run. We won't get a warning, right?
Yeah.
Okay, so that's the two main reasons for using examples. Okay, what's the next step after tests?
I think the body.
Okay, let's do it.
Now it's ifs, no?
Yeah. So it can be one
Uh,
of many choices. We need to use a conditional to determine which one.
and I can like do this as well.
You have to use two equals, double equals.
Okay.
Yeah,
Yeah, because it's okay. Like, like this, no?
sure. Keep going.
Like it's like this.
Yes, else if correct. Yeah,
And yeah. And you can just do else, no? Eh.
sure. Either way.
And now we only have to, yep, if in equals break, if in equals, hey, what is it? Equal plus, equal, equal. Mm-hmm. Stop. If in equals stop, then the next is go where I'm cheating because I'm using the test. But yeah,
Yeah, I
and
mean,
then
that's
the
why the test is there actually. The test helps inform you how to write the body of the function. That's why we write test first.
yeah,
Okay, let's run
and
it.
then you have to end, no? Here.
Oh yeah. Okay,
I did something wrong.
okay, well, yeah. Let's read the
Okay.
error messages.
Either simplify this block to a single expression or mark the other expression with block to indicate this is deliberate. What does that mean? Ah, like only, no, but it's different things. Maybe because, no, I don't get
Okay,
it.
so let me explain something. Um, I'm gonna comment out all this for now, and I don't know if I don't think we'll have time to finish this. So this will probably be our last thing. If you have time later in your own time, feel free to finish this function.
Mm-hmm.
Okay, I want to explain something, which is ifs in this language.
Okay.
If we run
If
right now,
true,
oh what?
I,
Oh,
I try to
sorry.
move the final state before the end, but I will return it. Okay.
Okay. Do you see this here? If true 0, else 1, we get 0.
If true, you print 0, else you print 1. Print 1.
Notice how we didn't write print.
No, no, but Pirate doesn't use print, no?
Yeah. So what if I do this? Do you see that?
X equals 0 or 1.
And we
No?
run it, we'll get back zero. You see that?
Uh, I'm running it, but I'm not seeing anything. Pirate didn't
Y-
understand your program.
What? Oh, okay, just look at my screen now. I think that's about. Can you
Yeah.
look at my Zoom screen? All right, if I run
Okay.
now, I get zero. This is what it looks like. So in
Uh-huh.
Pirate, ifs is an expression. It must provide an answer. Okay?
Yeah.
So the problem you are having here, this final state equals TL stop, that does not give an answer.
Yeah, yeah,
That's why
yeah.
it's
That's why
complaining.
I was putting final state before the end. No? That solves it?
Well, if you run this now, this is still incorrect.
No, 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 but
It's
final state before the end. Because the
like
if is the like final state at move it to line to
oh, okay,
98.
so I'll let you do that at your own time. We are out of time now. Um,
Uh,
okay, good work. We'll pick this back up next time.
okay, but okay, okay. I think my pirate is failing a little.
So
Uh,
okay, it takes a little bit to get used to, especially if you're coming from a different programming language.
and why did you choose pirate to teach? I know it's a teaching language, but
Yeah.
why?
For
Because I
example,
assume
like,
you know a lot of languages.
well, for example, this testing here in Python, this is not easy to do. In Python, you have to install a library, you have to install a package, and you have to do
Mm.
other stuff. But here, it just works.
Yeah, but if it's inside a package, it's just import package and no.
Well, I can't guarantee that every student knows how to do that easily, right? I have to start with a controlled learning environment.
Mm.
Anyway,
Eh,
there's many reasons why. That's one of the reasons. Okay, I do have to end here. I have to run.
okay, okay.
Okay, I
Take
hope you
care,
learned something today,
Marvin.
Frank, and I hope to
Yeah,
see you
yeah.
again. All right,
Yeah,
bye-bye now.
see you soon. Take care. Bye
Take
bye.
care.